Hello. I did a YouTube video about a backup circuit that I recently made, and there I promised to explain what is going on there. So it's been, I think, more than a week, and I did not find a suitable time. So even though it's uh, uh, in the middle of the night now, I will try to make it. I hope I will not have interference. If so, I will just pause the video. Now I'm with some software that records. I think it's called Snagit, and if you will see down here, there is a taskbar which I I developed through my tools software. You can find this software at the site linked below at the video description. Now, I wanted to do a simple backup circuit. So if I have, for example, a house with um, 12-volt appliances, and if this somehow falls, for example, this 12-volt uh, is supplied from a transformer from the the main rails of 200 or 220 or 110 volts, AC volts, or it may be supplied from a 12-volt battery from a solar system. Whichever case, if this falls, um, you want some other battery. I will draw a small battery over here that will get into um, order whenever the main the the supply voltage of this home falls. It can fall by various reasons. Maybe the battery is too low. Maybe the transformer had a shortcut. Maybe there was a shortcut, mm, short power supply of the electricity that the municipality give you. Whatever the case, you want another battery to get inside, to get into order and to sense this and supply the voltage very fast to the home. Okay, so first I will tell you what was the older version of my supply circuit, which I found somewhere on the web. I have to find it. Just a minute, I'm sorry. Mm, I will pause for a moment. Okay, I found it, that circuit. I know it. Generally, it's very simple. You have you have a battery. When I put these three lines below, it means Earth. That is a starting point for the voltage. It's like what is your height? Your height starts from the floor that you are standing. If you are standing on the second floor, it doesn't mean that your height is whatever your length from the second floor plus the first floor. No, it depends wherever you start. So that's the below here is the starting point. And you have a diode. Now, diode is uh, something falls over here, 0.7 volt. This side, the left side is higher from the right side of the diode at about 0.7 volt. There are many, there are Schottky diodes, there are other characteristics of the diode. I'm not going to get into that. That this voltage is a little less. Now, the home will connect, what was the color? I think this one. And the home will connect here. So what happens over here is that whenever and this battery is 12 volt, and here is also 12 volt, 12 volt. So this side, on the left side where this arrow here should be 0.7 volt above the right side in order for the current to flow. But once there is 12 volt on both sides, this means that no current will flow. That's nice and dandy. Now, if this on the right side, if the current falls, the battery take into charge and give its power to the right side. Now, the problem with this is that whenever if a lot of current needs to pass through this diode, it means a lot of current and there is 0.7 voltage. So the power will be a lot, and this means it will be warm, very warm. So you have to put a few diodes in parallel. For example, another one. Just a minute, I will erase this. Sorry. And another one and some more, but it will be very hot and a lot of power will be lost because these diodes become warm. So um, uh, this system, this circuit, even though this is the simplest way, there is, if you want to light an LED, to show to light an LED while the backup is running, you have to use this circuit. So this is one diode, and this is the backup battery over here. And once this side is the home side, and once the home is falls, that these 12 volts pass through this diode and this diode. I'll tell you later why I put two of these. And if there is 0.7 volt over here, it makes this PNP transistor conduct from the emitter to the collector, and this lights this LED that indicates that the circuit is running now and we are running on a backup circuit. Now, I put another diode because sometimes the battery is too high over here, and on the contrary, at home there is a lot of load and the voltage drops. So if the voltage drops above 0.7, or in this case 1.4, which is twice 0.7 volt, this battery start to conduct to the other side, and while it's conducting, it depletes the battery and it will not do the good job that it was supposed to be doing. So this circuit is good for small appliances, and I will tell you what kind of appliances. For example, where is my cursor? There is a clock, my clock. Let's sign it like this: electric clock, and you connect a diode to it, and you connect a battery to it as well. This is ground as usual, and this is plus. And for this clock, there are other appliances that are connecting. For example, I don't know, some light, yes. And this have ground also. And something else it has, I don't know, let's say, what else do I have? A refrigerator, just for demonstration purposes. Refrigerator over here. So what happened to me is that whenever all the electricity fell, this battery tried to supply voltage not only to the clock, but to all other appliances. And of course, if this battery is small, you know, 3 times or 4 times, 6 times AA batteries, it cannot back up all the system. So what I did here is I added here another diode. So once the big battery is connected, for example, over here, oh, the cursor is nearly invisible, and I have to fix that. This is an applet that I took, free applet, and sometimes I make changes, but only when I use the applets. And this is, I think, the first or second time I use it for after a very long time. Really little I use it. So whenever, so I have, maybe I will have time to fix some errors here. So now, if the battery is falling, this the this battery will make the clock a backup clock, but will never be able to pass to the whole network. So that's good because I have a lot of shortcuts at my home. Most of them I do by myself while they're doing experiments. and sorry, and I don't want to titrate the clock every time I have a shortcut. And the clock, of course, is connected. Once it was connected to 220 volt and transformer. Now it's connected directly to the rails. So this gives me a nice backup to the clock only, and the battery can stay with the voltage, leakage ampere of amperage of less, I think, less than 1 micro. That it can last, if not in use, for a few years. If it's in use, it depends how much the clock consumes and for how long the battery backed it up. So that is a simple circuit. And the next video, I will tell you what I tried to do, and the video afterwards, I tell you what I'm um, refurbished or second version for the first version that I did by myself. Thank you for watching.